Assalamualaikum and good morning everyone. My name is DANISH AFIQ. Today I want to talk about drying curve. So we start from the definition. A drying curve represents the drying process of a material and is typically plotted with moisture content on the y-axis and drying time on the x-axis. It illustrates how moisture is removed from the material over time under specific drying conditions. Next, we go for the stage of drying curve. I have provided a figure to explain this part efficiently. The drying curve typically consists three main stages. For the first stage is constant rates. The constant rate stage is depicted as the horizontal segment AB on the drying curve. During the stage, the drying rate remains constant. This stage occurs when the surface of the material being dried is saturated with moisture. The rate of moisture evaporation from the surface is equal to the rate of heat transfer to the surface. The moisture at the surface evaporates readily, maintaining a constant rate. Stage is first falling rate stage. The first falling rate stage starts at the point P and end at point C on the drying curve. The drying rate begins to decrease gradually. As the surface moisture is depleted, the drying rate starts to fall. The moisture now has to move from the interior of the material to the surface to evaporate. The movement of moisture is slower than the surface evaporation rate, causing the drying rate to decline. Next, we have second falling rate stage. The second falling rate stage starts at point C and continue until point D. The drying rate decreases more rapidly compared to the first falling rate stage. At this stage, the material has significantly lower moisture content. The moisture is bound more tightly within the material and the internal diffusion becomes even slower. The drying rate is now heavily influenced by the internal structure and properties of the material. The last stage is EMC, equilibrium moisture content. It's the moisture level at which the material neither gain nor lose moisture when exposed to a given environment. In the state where the internal moisture content of the material is in balance with the moisture in the surrounding air. On the drying curve, EMC is represented at stage 5, where the dry with moisture content curve, blue lines, flatten out. This flattening indicates that the moisture content of the material has stabilized and no further drying occurs despite continued exposure to the drying condition. Next, for part of importance of drying curve. The first important is efficiency optimization, for example, energy consumption. By analyzing the drying curve, operators can identify the most energy-intensive stage of the drying process and optimize conditions to minimize energy use. Next example is time management. Knowing how long each stage of the drying process takes allows for better scheduling and throughput in industrial operation, reducing downtime and increasing productivity. Next is product quality assurance. For example, moisture content. The drying curve helps ensure the products are dried to the correct moisture content, preventing over-drying, which can lead to brittleness, and under-drying, which can cause spoilage and microbial growth. The last part is application of drying curve in industry. The first one is for dry fruit and vegetable. Ensuring dry fruit like apricots and raisins reach the desired moisture content to maintain chewiness and flavor. Using the drying curve to determine the optimal drying time and temperature to prevent over-drying, which can lead to hard and unpalatable products. Second one is for dry snack food. Achieving the desired crunchiness in products like potato chips and crackers. Utilizing the drying curve to balance moisture removal and oil contents, resulting in a crispy texture without excess oiliness. That's all for me. Thank you for watching.